Hi, we are talking today about Module 13, which is ICMP, Internet Control Messaging Protocol. So ICMP, both version 4 and version 6 messages. Again, Internet Control Message Protocol provides feedback about issues related to the processing of IP packets under certain conditions. So obviously ICMP v4 is for IP4 and ICMP v6 is for IP6. So ICMP messages are common to both, or some common to both, are host reachability, so whether or not you got the actual host itself, destination or service unreachable, and time exceeded. So ICMP version 4 messages are not required and are often not allowed within a network for security reasons alone. Now, your ICMP echo message. This can be used to test the reachability of a host on an IP network. So in this example here, the local host sends an ICMP echo request to a host. If the host is available, the destination host will respond with an echo reply. So obviously, when we are doing these ICMP echo messages, we are utilizing the ping command. So a destination unreachable message can be used to notify the source that a destination or service is unreachable. The message will include a code indicating why the packet actually could not be delivered. So a few destination unreachable codes for ICMP4 are 0 for net unreachable, which means the network itself, a 1 for host unreachable, meaning the destination host could not be reached, a 2 for protocol unreachable, which means the protocol is not functioning or it is unreachable. And the number 3 is port unreachable, meaning the port that you're trying to access is not open. Within ICMP v6, 0 means there is no route to the destination. A 1 means communication with the destination is administratively prohibited, meaning there is a firewall in place. A 2 is beyond the scope of the source address, so can't be reached because it is too far away. 3, the address itself is unreachable. And then 4, again, is that port is unreachable. So ICMP version 6 has very similar but slightly different codes for destination unreachable messages. So when the time to live, and we talked about time to live or TTL in previous discussions, when this field in a packet is decremented to 0, in ICMP v4, a time exceeded message will be sent to the source host. ICMP 6 also sends a time exceeded message. However, instead of the IP4 TTL field, in ICMP 6, it will use a hop limit field to determine if the packet has in fact expired. So while you're doing your labs, again, your device is always giving you information, feedback to your question. Your question here is, I want to ping something. In this case, we want to ping or test connectivity to 8.8.8.8. Now, just because you get a reply, a lot of times a misconception from a student is, if I get a reply, that means it's good and it's worked. However, you do need to pay attention to the message after the colon. That message tells you everything. So if you're looking down the bottom here, you're looking at packets sent for, received for, there's no loss, but pay attention to the message. The TTL expired in transit. Okay, so we didn't lose any of those 4 packets that were sent out, but it also never got to the destination because your TTL expired. your time to live. Now, time exceeded messages are used by the traceroute tool, which you are also familiar with. So within ICMP version 6, there are a couple of new features and improved functionality that is not found in 4, including 4 new protocols as part of the Neighbor Discovery Protocol. So when we talked about Chapter 12 and we talked about IPv6, these same types of messages is what was utilized in order to do neighbor discovery, which is very similar to ARP in IP4. So messaging between an IP6 router and an IP6 device, including dynamic address allocation, are as follows. Router solicitation means a device is asking a router for IPv6 configuration parameters. A router advertisement is the router actually answering the request. Okay, so solicitation is the client asking. And advertisement is the router answering. Now, messaging between IP6 devices also include duplicate address detection and address resolution. So neighbor solicitation messages between IPv6 enabled devices and neighbor advertisement messages. Now, ICMP ND also includes the redirect message, which has a similar function to the redirect message in ICMP version 4. Now, RA messages are sent by IPv6 enabled routers every 200 seconds to provide addressing information to IPv6 enabled hosts. And again, do not forget the command that is utilized to tell a router to do this functionality is the IPv6 unicast routing. So RA messages can include addressing information for the host, such as the prefix length, DNS address, and the domain name. A host that is using stateless address auto configuration, which again is the default, to the link local address of the router that is sent to the RA. Will set its default gateway to the link local address of the router that is sent by the RA. So whether we go in there and manually configure, as you see here with the FE80 :1 command, that would be used as the default gateway for everybody in that LAN, or if it actually generated its own without our interaction. So whenever you see FE80 :1, that is us interacting with and statically assigning that link local address. Now, an IPv6 enabled router will also send out an RA message in a response to an RS message. So in this figure here, PC1 sends an RS message to determine how to receive its IPv6 address information. Remember, there were 3 different ways that we could get that information. Slack, which is the default, Slack with stateless, which is getting the IP configurations from the IPv6 router, and anything else like DNS, any other kind of parameters from the DHC v6 server. And then the last one was stateful, which is getting all of the information from the server itself. So R1 replies to the RS with its RA message. So PC sends a message that relatively says, hey, I just booted up. Is there an IPv6 router on the network? I need to know how to get my IPv6 address information dynamically. If router 1 has been configured to act as an IPv6 enabled router, then it would answer with, hi, all IPv6 enabled devices, I'm router 1. And you can use Slack to create an IPv6 global unicast address. The prefix is 2001, colon, DB8, colon, ACAD, colon 1, double colon with the prefix of 64. And oh, by the way, use my link local address of FE80, double colon 1 as your gateway. A device assigned a global IPv6 unicast or link local unicast address may perform that duplicate address detection. So again, the duplicate address detection was a router sending out a request, much like an IP version 4 ARP request. It will send out a message with that IPv6 address that it got from the router, or even if it generated it himself. And it would send out a message saying, hey, is there anybody out there that has this address? Now, if somebody out there has this address and responds, then that PC or end device will not take on that IPv6 address. It will search again for another IPv6 address. If, however, nobody responds to that DAD message, then it will consider that no one else is utilizing that address. It will take it on as its own, and then it'll automatically assign the router's the router's link local address as its default gateway. So this DAD message is to check the uniqueness of an address. So DAD is not required, but RFC 4861 does recommend that DAD is performed on unicast addresses. Now, to determine the MAC address for the destination, the device will send an NS message to the solicited node address. The message will include the known targeted IPv6 address. That is the difference between just a regular NS and an NS to a solicited node. The IPv6 is a specific target address. The device that has the targeted address will respond with an NA message containing its Ethernet MAC address. So in this figure here, R1 sends an NS message to the 2001 colon DB8 colon ACAD colon 1 double colon 10, asking specifically for its own MAC address. So a solicited node or a message to a solicited node is going to a particular device. Now, the ping command is an IPv4 and 6 testing utility. It uses echo requests and replies to test connectivity between hosts and to provide a summary that will include the success rate and the average round-trip time to the destination. So as you see in the output here, both IPv4 on the top and IPv6 on the bottom, as we have already learned, best case scenario is exclamation points, 5 exclamation points. And don't forget what you know about a single exclamation point, a single timeout for the very first communication. So in the top one, when you see a period here, okay, don't forget, this is ARP in process. Okay, now if you were to do an up arrow on that very top one and hit enter again, you should get 5 exclamation points. When you ping again to another address in your IPv6 world, you also get 5 exclamation points. That is complete connectivity. So down the bottom, your success rate is 100%, meaning you sent 5, you got 5, and it also tells you the time of your round trip. We can also use ping when we talked a little bit before about those baselines, trying to create a baseline for our network. Ping command and traceroute, those are the 2 commands in Windows that we could actually utilize to create our baseline. And what you do is you pay attention to how many milliseconds it took to go from source to destination. And you do this multiple times a day to the same device. And then you do it for a span of at least 1 to 2 weeks. That gives you a baseline that says, okay, this is what my traffic looks like when it's running perfectly normal. And then same thing with trace route. If a reply is not received within the time out, ping provides a message that will indicate a response was not received. It is common for the first ping again to be timed out if address resolution ARP or ND needs to be performed before sending the ICMP echo request. Now, as we go through our testing, and we talked about our testing before, first thing you want to do is make sure you are not the problem. So I do this by pinging my own TCP IP stack. So if I go in and I use either under IPv4 or IPv6 on the local host, if I ping 127.0.0.1 for IP4 or :1 for IP6, and I get a response, then that means IP is properly functioning on my machine. This should always be your first test in troubleshooting. Always take yourself out of the dynamic first. Now, if you get an error message, that's going to indicate that your own TCP IP stack is not operational, and this is where you start your troubleshooting. The ping command can be used to test the ability of a host to communicate on the local network. The default gateway address is most often used because the router is normally always operational. Now, a successful ping to the default gateway indicates that the host and the router's interface serving as the default gateway are both operational on the local network. If the default gateway address does not respond, a ping can then be sent to the IP address of another host on that local network to see if that host is operational. If that host is operational, now you can start troubleshooting at your default gateway parameter. And then lastly, once your default gateway is successful, now you can ping a remote host. Okay, so a local host can ping a host on a remote network. A successful ping across the internetwork confirms that you have communication on the local network as well as across and into a remote network. Many network administrators, however, limit or prohibit the entry of an ICMP message. Therefore, the lack of a ping response could be due to security restrictions. So your testing sequence is going to look like this. So if 1, 2, and 3 are all 3 successful, then you do 4. Okay? If 1 is unsuccessful, troubleshoot. If 2 is unsuccessful, troubleshoot. If 3 is unsuccessful, troubleshoot. Okay, this gives you information to say this is where I should start my troubleshooting processes. wherever you are not having connectivity or getting echo replies. Now, traceroute actually tests the path. So traceroute will tell you, and this is based on how many hops. And don't forget, a hop is equal to a router. So traceroute and traceRT is a utility that is used to test the path, between two hosts and provide a list of hops that were successful or successfully reached along the path. So traceroute, as you see here, is used on an intermediary device. And traceRT is used in command prompt on your PC. Okay, you have to get that distinction. Okay, when you're in a device, it's usually that powder blue window that I have. By default, we change it to the powder blue just to make it more pleasingly adaptive. By default, it is black and white. So used in command prompt on your PC is traceRT. Now, when you need to abort, let me just put this as a side note because I don't want to forget this. If you do either a ping or a traceroute, there is a command that you could also put in there. It is a switch or an option, whichever way you want to look at it. So if I do traceroute -T, and then the IP address. Okay, what that T option does is it will execute that command endlessly. It gives your device more time, if needed, to get to the actual destination. So if you do this and you try this, and I do encourage you to try it, it works just as well on the ping command. It is continual. It is just to give you more information or your device more information to be successful or to get further through your network if need be. When you get hung up in this on your PC, it is going to be Control break or Control C to get out of it. So on your PC, on your network devices, it is Shift X. Okay, so this is to abort that process. Okay, so be aware of that. So going back up, traceroute provides round trip time for each hop along the path and indicates if a hop fails to respond. Your asterisk is used to indicate a lost or unreplied packet. So in this particular example, you had success. Okay, so if your target, and it was 192.168.40.2, okay, this is who I was trying to reach. And my last indication here is I actually reached right there. If, however, if there was loss anywhere along the line, you would just get a continual asterisk. This information can then be used to locate a problematic router in the path or may indicate that the router is configured not to reply. Traceroute makes use of the function of that TTL field in IPv4 and the hop limit field in IPv6 in the layer 3 headers along with ICMP time exceeded message. So I know I've gone through the examples before where in the steps to traceroute. So if you have 3 routers in your scenario, your TTL for the first time would be 1 because it would decrement at 1. So if it reaches the first router, then that's the first entry. Next time out of the gate, you will get a TTL of 2. TTL 2 will stop at 1 and then go on to 2, and then that will be your next entry. And for the third router, you would have a TTL of 3. So this is how traceroute builds this list. The first message sent from traceroute will have a TTL field of, I think I just said this, I apologize guys. So we'll have a TTL field of 1. This causes the TTL to time out at the first router. This router will then respond with an ICMP version 4 time exceeded message. Traceroute then progressively increments the TTL field for each sequence of messages. This provides the trace with the address of each hop as the packet times out further down the path. Your TTL field will continue to be increased until the destination is reached or it is incremented to a predefined maximum. If it gets to 0 and there is nothing else left, it will be dropped. So that is a little bit about ICMP.